Welcome back. This is 7.4, Fundamentals of Probability. So our objectives are compute the theoretical probability and compute empirical probability. So probabilities are assigned values from 0 to 1. So 100% is 1. So we're converting it to decimals. And then 0% is 0. So 50% would be 1/2 or 0.5 for that probability. So a 0% would be impossible, or a 1 would be certain that it would happen. All right, theoretical probability is an experiment. An experiment is any occurrence for which the outcome is uncertain. A sample space is a set of all possible outcomes of an experiment, denoted by S. An event, denoted by E, is any subset of a sample space. And the sum of the theoretical probabilities of all possible outcomes is 1. All right, computing theoretical probability. So if an event E has NE equally likely outcomes, and its sample space S has NS equally likely outcomes, the theoretical probability of an event E, denoted by P of E, is number of outcomes in event E, so N of E, and total number of possible outcomes is N of S. So N just represents number. So let's try an example. So it says a die is rolled once. Find the probability of rolling a 3 and then finding that you get an even number. So the sample space is 6 because dice are 6-sided. So there's only one way to roll a 3, so it'd be 1. And then your sample space is 6, so it'd be 1 out of 6. Rolling an even number describes the event E, so 2, 4, or 6. This event can only occur in 3 ways, so your N of E is 3. And then it's still that same sample space, so 3 out of 6, which equals 1/2. So it's more likely to get an even number than it is to get a 3. All right. Let's look at 2 other possibilities. So rolling a number less than 5 and a number less than 10. So your sample space is still 6 because dice are still only 6-sided unless you play like Dungeons and Dragons and have the multi-sided dice, but we're just looking at a regular sided dice. So the phrase rolling a number less than 5 describes the event 1, 2, 3, or 4. So this event can only happen in 4 ways. So your N of E is 4, and then there's still 6 possibilities. So 4 out of 6 reduces to 2 out of 3. So a 2/3 probability. All right, rolling a number less than 10 describes the event 1, 2, 3, 4, 5, 6. So any sides on the dice are less than 10. So that's event is 6. So 6 out of 6 equals 1. So anytime you'll roll that dice for that sample space or that event that's less than 10, you'll always get that number less than 10. All right. Another example. So a dice is rolled once. Find the probability of rolling a number greater than 6. So still our sample space 1 through 6. So the phrase rolling a number greater than 6 describes the events that cannot occur or an empty set. Thus, E is an empty set, or N of E, and N of E is 0. So you'd have 0 over 6, which is 0. So that would be your empty set. Because none of your numbers on a regular sided dice are greater than 6. If it said greater than or equal to 6, then we would have that one possibility. But since it didn't specify that it has to be a number greater than 6, it is 0, so that's that empty set. All right, so let's look at examples using a deck of cards. So it tells you that your deck is 52 cards. So you are dealt one card from a standard 52 card deck. Find the probability of being dealt a king, a heart, and then the king of hearts. So probability of getting a king. So remember there's 4 different shapes on your cards, or faces, they call them. So you have your hearts, your diamonds, can't draw diamonds, your clovers, oh gosh, and your aces. So those are your 4 options. My drawing is super bad, so don't judge me. Okay, so there's 4 of each. So 4 possibilities of getting a king out of 52. Then you would reduce that, and it would be 1 out of 13. All right, how many heart outcomes? So remember you have numbers. So you start with ace. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have jack, queen, and king. So those are 13 possibilities for one suit, they call it. So 13 out of 52. So that'd be 1 out of 4 cards. All right, probability of getting a king of hearts. So there's only 1 king of hearts in a deck out of 52. And we can't reduce it, so we would leave it. All right, empirical probability. So that applies to situations in which we observe how frequently an event occurs. So computing empirical probability, it says observed number of times E occurs over the total number of observed occurrences. So let's look at some examples. So computing empirical probability, in 2015, there are approximately 254 million Americans ages 15 or older. The table shows the distribution by marital status and gender of this population. Numbers in the table are expressed in millions. So if one person is randomly selected from the population described above, find the probability that the person is divorced or a female. So let's look at that. I'm going to keep mine together. It says, so the probability of selecting a divorced person is observed by the number of divorced people, so 26 million. So that's the total. Divided by the total population. So 26 divided by 254. So, and that's approximately 0.10 if you put that in your calculator. All right, next, so the total number of females, so that's here, divided by the total number of population. So 131 over 254, put that in your calculator, and it's approximately 0.52. So 52% chance of selecting a female, and then 10% chance of selecting a divorced person. All right, and that is it for 7.4. If you have any questions, please let me know. Otherwise, work on your assignment.